Hello everyone, I'm Dr. Shiv Kumar, Head of the Department, Civil Engineering, GIMS Engineering Management Technical Campus, Greater Noida. Today, in the series of these lecture belongs to Building Materials and Construction, we will talk about smart construction materials. We should discuss about their application, the types of smart construction materials and nanomaterials, and how they are being applied in that construction field. So let's start with the introduction. So these smart construction materials are also known as intelligent materials, adaptive materials, because they have that capability to respond to the change in their condition with respect to the change in environment. They are also useful and in a controlled manner. The input that cause the change in the smart materials properties may be in the form of mechanical stress, magnetic field, there may be a strain, there may be an electrical field. So, or the change may be due to temperature, moisture, pH, and sometimes light. These materials have some unique properties which make them a very different and crucial materials, and hence it is applied in the field of engineering and sciences. They are used in civil engineering projects and contribute in increasing performance, comfortability, and energy efficiency of the structure. So let's start with the types of smart materials. In this series of smart materials, the first material is shape memory alloys. So as shown in the figure, if you see, then these are the materials they are given some rods, you have seen that. So the lowest rod, which is at the normal temperature, room temperature, and which is straight in the shape. And if we heat up and put some forces, then the bar, you can see there may be a bending due to some stress, some force. And after that cooling, we have seen that the purple color, after the cooling, it retain or regain its shape. So such material possess the ability to regain to some previously defined shape or size when subjected to appropriate thermal changes. The shape memory alloys find their applications in new application like in seismic protection, or you can say that the protection from the earthquake. Here we can see another picture in which we have applied some force in the middle and the shape was deformed. So it has shown in the figure in the form of arrow. So this is the deformed shape of that bar, and after the heating, it again regained to its original shape. So this is called the smart alloy or memory alloys, which is used in the construction field. The next is the magnetostrictive materials. So as far as these magnetostrictive materials are concerned, so these materials, when applied or when undergoes electric field or a magnetic field, the material change its quality or its shape. So in the figure, you can see that there is no magnetic field, and when we applied the magnetic field or electrical field, the particles present in that or the material, they change its shape. That is why the name magnetostrictive materials given to these materials. These materials show promise in application ranging from pumps and valves to aerospace wind tunnel. Now, the third one is the piezoelectric materials. As the name electric, so it means there may be some change. So these piezo electric materials, they possess the capability to produce voltage when surface strain is introduced. Conversely, the materials undergo deformation, oblique stress, when an electric field is applied across it. So when integrated into a structural member, a piezoelectric material generates an electric field in response to the mechanical forces. The next is electrorheological fluids. So these electrorheological fluids are undergoes changes in the viscosity. They are in the colloidal suspension when subjected to the electric field. Such fluids are highly sensitive and respond instantaneously to change in the applied electric field. Find their application in shock absorber. So here you can see in that image, in the first image there is no electric field. Then you can see that the particles or molecules that they are in the free state. And when we apply the electric field from upward and downward direction, then you can see that the beaded structure, like the beaded structure is formed, the molecules, they get connected to each other. And after when we remove that electric fields, then again it regain its shape. The next is electrochromatic or electrochromic materials. These materials alter their light transmission property when voltage is applied. So when the temperature is low, so light transmission capacity is comparatively low. And when the temperature rises, the brightness or the light transmission properties of the material is increases. So that is why it is called the electrochromic. Chromic means the color. Color means light. That may be a dark, that may be a light. Now come to the application part of the smart materials in construction. The smart concrete, which is used in the construction industry, which is composed of the carbon fibers and concrete, which is used in the smart structure, and it is capable of sensing minute structural failure problems, or which is known as that, or which is defined as the cracks and flaws. Unlike conventional concrete, the smart concrete has higher potential of enhanced strength. It can be used in electromagnetic shielding. Smart concrete undergo loading and unloading process will lose and regain its conductivity, thus serving as a structural material as well as a sensor. So secondly, a smart material have application in the design of smart buildings. These smart materials are used to control the vibration, noise mitigation, safety, and also the performance. So in a smart building, it is used to transform efficiency, comfort, safety, health monitoring, environmental control, etc. Also, these smart materials can be used in reduction of earthquakes, or you can say that it reduce the impact of earthquake in the building. So in marine and rail transport application, the strain monitoring using embedded fiber optic sensors. The use of smart materials permit the construction of smart bridges, especially cable stayed bridge, which are wider span to avoid the increased susceptibility to vibration caused by ambient factors. So that may be a wind, that may be a rain, that may be a traffic. Hence, the structure required less maintenance, and the response to the structure can be monitored. So these are the basic application part of the smart materials. So smart materials, the structure used to monitor the integrity of bridges, dams, offshore, oil drilling, towers, where fiber optics sensors embedded in the structure are utilized to identify the troublesome areas. So these can be used to rehabilitate or cracking of concrete when superelasticity smart materials is used as a reinforcement bar. So here you can see in the image, this is the smart concrete in which these reinforcement, super elastic reinforcement has been provided. Now come to the details of smart bridge. So what are the components we add to the bridge to make it smart? So here you can see that the attached embedded sensors, here we can see that in the red line in the pillar. So this is the sensor, steel FRP jacket, the sensor which is covered by the steel FRP jacket, then actuators and LVDT. You can see here with the base of the pillar. Here you can see that the local control unit which is connected to the local control unit and command center. And this is the bridge deck. Here we can see that the solar panel, wireless telemetry, and steel FRP reinforcement and fiber optic sensors. So all these things make the bridge smart, or this smart application. By the application of these smart materials, we can construct, we can make the smart building or a smart structure. Now come to the geosynthetic materials. This is the another kind of material which is used mainly in making of macadam roads or pavements. So these are the various types of geosynthetic materials which is widely used in the civil engineering and construction work. So properties, function and uses of geosynthetic materials will be discussed in this lecture. The depleting sources for granular and other elementary raw materials, combined with the limited availability of funds for the projects, has been generated new opportunities like आवश्यकता ही आविष्कार की जननी है. So it is more or less based on that. So it has been seen that we can generate the new opportunities for innovation, engineering to achieve cost-effective solutions. So geosynthetic materials are considered as the bona fide engineering materials, which are not only that filling for the scarce raw materials like cement and steel, but also they are turning out to be very pretty, sound, and good alternative to the conventional designs. So here you can see in that image, here we provided the mesh in the pavement and which is covered by the codes of the bituminous road. So this provide this increase the strength of the road and life and durability also. So the use of geosynthetic material is though still novel in the construction industry, it is used nevertheless increasing every year in this sector, such as reinforcement to fill, management of poor water pressure, foundation and pavements. Apart from the being economical, they can be rapidly installed, and also by this way we can control the quality because it is a factory manufactured product. Geosynthetics now considered the necessary and indispensable for an economical solution in multiple functions such as reinforcement, separation, filtration, drainage, erosion control, and also containment and protection. So these geosynthetic materials are nothing but planar polymer materials used in contact with the soil, rock, or any kind of geotechnical materials that may be used for the filtration, that may be used for the drainage, used for the separation, reinforcement. Also, they can be used for the protection, sealing, and packaging or packing. Now come to the types of geosynthetic materials available in the market. So first one in this series is geotextiles, geogrids, geonets, geomembrane, prefabricated vertical drains, geosynthetic clay liner, geocells, and geocomposites. So based on the function, or how and where we can use these geosynthetic materials, which we will discuss in this slide, like they can be used in the soil reinforcement to protect soil from the erosion. The basal reinforcement is to support the soil reinforcement structure. Also, it increases the bearing capacity of the soil. The separation between the in situ soil and the imported soil to avoid mixing and reducing mechanical performance. The filtration behind all hydraulic structures, drainage control at the top, 8 meter to collect any seepage water coming from the other sides of the embankment to avoid contamination on the structure fill, erosion control that I have already mentioned. Now come to the uses of geosynthetic materials in this table. We will talk about the properties of geosynthetic materials. Like if we talk about the geotextiles, they can be used in separation, reinforcement, filtration, and drainage, while geogrid is applied only in the reinforcement. Geonet, they can be used better used in that drainage system, and the geomembrane we can apply it in the containment area. Geosynthetic clay liner, this is also we can apply in the containment. Geopipes, we can apply in the drainage. Geofoam in separation, and geocomposite, they have wide application in all the fields like separation, filtration, reinforcement, drainage, and containment. Now, the separation of soil layer, how the soil gets separated. In order to keep the imported material separated in situ soil, which we have discussed in that, the point has been mentioned in the previous slide, a separating layer of geosynthetic is laid between the geotechnical entities. So here is the soft clay, and we applied the geotextile in between them, and then finally we applied the coarse grained soil above the geotextile. So here this cannot be mixed and cannot alter the mechanical property under any kind of action or any kind of applied loads. So depending upon the surrounding condition, non-woven geotextile, geofoam, and geocomposites can be laid in between the imported materials and in situ soil. They are usually applied at sub-grade, sub-base interface in the temporary or the permanent roads. So between railroad, blast, and foundation soil, the between embankment fill and the soft foundation soil. Now we can see that the filtration of the water. Here we can see that the geomembrane. The mismanagement of water on site is capable of causing extreme harm. Soil erosion in the particular area, the most harmful and to the structure could lead the carelessness and repercussions. It often results in the formation of irreparable gullies, hence to help prevent that from the happening, a geocomposite clay liner, which is known as the GCL, is placed underneath all the hydraulic structures. This is a costly option. Therefore, to remain within the budget, it is also suggested to use non-woven geotextiles. Drainage works. If water is not contained properly on the sides, so the increase in the pore pressure often requires a surplus amount of reinforcement of about 50%. To avoid this, geocomposite liner is installed using at the back of the reinforcement structure with the perforated pipes at the bottom to collect the water. The pipe is then connected to a hydraulic structure. Now come to the soil reinforcement. Here we can see that the basal reinforcement which has been provided. Here you can see in the first image a even spaced, even length. Here you can see that the black dots which is applied for the basal reinforcement. In the B image, uneven, this is called uneven. Here we can see that the even spaced, even length with short facing layers. This is the facing, short facing. And here we can see that the short facing layers even spaced, uneven length. So length is uneven, you can see that, which is shown by the dotted yellow line. So basal reinforcement is provided at the foundation level of the reinforcement structure at the standard penetration test is conducted to assess the soil bearing capacity. Yeah, as I have mentioned in the previous, that these geosynthetic materials can be used to increase the bearing capacity of the soil. Where the soil bearing capacity is comparatively low, then we can provide this kind of soil reinforcement. Here we can see that the another kind of the soil reinforcement, geosynthetic reinforcement is provided, and this is the facing panel, and this is granulated soil, just to protect land from the slide or soil from the slide. Next is soil erosion control. Here you can see in that image, this is the geosynthetic material. So it is the slope. So to protect soil from the erosion, it is covered with that geosynthetic textile fiber and geotextile so that erosion can be protected. This is the non-woven type of geotextile, act as a filter, separator, drain, and also act as a reinforcement. Now come to the another topic, which is known as the nanotechnology. So as far as the modern construction is concerned, so nanotechnology have played an important and crucial role to enhance the structural stability, strength, and contribute the other properties to the concrete. The question of where nanotechnology will take us in the construction industry, then it should be considered not only for the enhancing material properties and also function as but also the context of the energy conservation. So I'm telling about that to avoid this. Yeah, we are talking about this is a particularly important prospect since a high percentage of all energy used, example 41% in the United States, is consuming by commercial building and residential houses by application, such as heating, lighting, and air conditioning. So several applications have been developed for this specific sector to improve the durability and enhance performance of construction component, energy efficiency, safety of the building, and facilitating the ease of maintenance and to provide increasing living comfort. Though Teflon, polysilicone based coating, etc., now they can add some property to the property. These are the self-cleaning materials by which the building can automatically get cleaned. The nanoparticles of TiO2, titanium dioxide, Al2O3, aluminum oxide, and zinc oxide are applied as a final coating on the construction ceramics to bring this characteristic to the surface. So TiO2 is considered as the self-cleaning material. So it can also remove the stain which is on the surface of the wall through the photocatalytic reaction. So TiO2 is being used for its ability to break down dirt or pollution when exposed to UV light and then allow it to washed off by rainwater on the surface like tiles, glaze, glasses, or the sanitary ware. Same ZNO is used to have the UV resistance in the both coating and paints. Nano-sized aluminum oxide particles are used to make the surface scratch resistant. These surfaces also prevent the declarate formation of the bad smells, fungus, and the molds. Here we can see the building, the Jubilee Church in Rome, which is built with photocatalytic active self-cleaning concrete made by the company Itala Cementi. So Ital Cementi, which is this cement is the TiO2 is mixed in the cement, and the construction of the building was taken place with the cement, and this is the self-cleaning property because in the UV presence of UV light, the TiO2 worked as a self-cleaning agent and removed the stain, oxidize the stain. Now come to the construction use of nanomaterials in the construction industry. The first one is the carbon nanotubes. Expected benefits are mechanical durability and crack prevention in the cement, It enhances the mechanical and thermal properties of the ceramic, real-time structural health monitoring, and effective electron mediation in the solar cells. The second is the silicon dioxide nanoparticles. These are expected benefits of reinforcement in the mechanical strength in concrete. It is also used as a coolant, light transmission, and also it is a fire resistant material. It is provide the flame proofing and the anti-reflection in the windows. So by the coating of the silicon dioxide nanoparticles, we can reduce the reflection from the surface. We can make the building heat resistant or fire resistant. It acts as a cooling material. So by the application of this silicon dioxide, we can increase the energy efficiency of the building. Now, next is the copper nanoparticles. Expected benefits are weldability, corrosion resistant, and formability in the steel. Silver particles or nanoparticles, their expected benefits are biocidal activity in coating in paints. Like it never allows any microbial growth on the surface. And quantum dots, expected benefits are effective electron mediation in the solar cell. The next is the titanium dioxide. As I have mentioned, the multiple uses of or work of this titanium dioxide. It increases the degree of hydration. It is having the self-cleaning property in the concrete, superhydrophilicity, anti-fogging, and fouling resistance in the window. Iron oxide, expected benefits increase the compressive strength and also provide the resistance against the abrasion of in the concrete. So this is about the smart materials, geosynthetic materials, and this was the last lecture of this series, building materials and construction. So thanks to all of you, many thanks to attending all the lectures of this building materials and construction. Thanks to all of you once again. Goodbye.